Okay, welcome to the first video on squares and square roots. We're first of all going to look at some definitions. So for example, a factor. A factor is a number that divides evenly into another number. So let's look at factors of the number 12. So factors of 12 are 1, 2, 3, 4, 6, and 12. We can rule out 5, 7, 8, 9, 10, 11 because those numbers do not go into 12 evenly. These are only numbers that go into it evenly, so that when you divide 12 by these factors, you will end up with an integer or a whole number. Let's look at 9. For example, 9 has factors of 1, 3, and 9. None of the other numbers go into it evenly. Okay, so those are factors. Factors are smaller numbers that we can break a number into that divide evenly. Prime factor or prime number is a number that can only be divided by 1 and itself. So for example, if I looked at the value of 7, 7 only breaks down into 1 times 7. So 1 and 7 are factors of 7. So 7 is a prime number because it only has 1 and itself that go into it, and both 1 and 7 are prime numbers as well. Another example would be 13, because 13, the values that are factors that go into 13 are only 1 and 13. No other numbers go into 13, so this is a prime number, and 1 and 13 are the prime factors. So we're going to be breaking down numbers into prime factors. So let's look at how to do prime factorization. So this is prime factorization, or sometimes it's called the factor tree. So we're going to do that for both 24 and 36 and we're going to break it down into its prime factors. So first of all, we find two numbers that multiply to 24, or the first two factors you can think of that get to 24. Well, there's a bunch. There's 12 and 2, 8 times 3, 6 times 4. So let's just stick with 6 times 4. You could pick any of them, and as you break these numbers down, you'll end up with the same prime factorization at the end. If I look at 6, 6 can be broken down further into 2 times 3. 4 can be broken down further into 2 times 2. Notice I put multiplication signs in everything. So this is your prime factorization because none of those numbers can be broken down further. 2 is the smallest we go. We don't go to 1. So 2 is the smallest, and all of those numbers are prime numbers, 2, 3, and this is how we do prime factorization. 36, again, you can break this into multiple numbers, 12 times 3, 6 times 6. Let's do 6 times 6. And then I know that 6 can break into 2 times 3. And also 6 can break into, again, 2 times 3. Now you'll notice with 36 that we get two values that are the same, 6 times 6 right off the bat. Or you can find those. This will become important later. And the fact that we can actually group these two prime factorizations, 2 times 3, and you find two groups of them. That's also important. Because what that leads into are perfect squares, numbers that have two identical factors. So for example, as we saw above, 36 is one of them. 36 is a number that breaks down into 6 times 6. I could look at 9 as another example that breaks into 3 times 3. You could look at a bunch. You could look at 16 that breaks into 4 times 4, and so on. You can list these off fairly easily by just starting off with 1 and multiplying it by itself. 2 times 2 is 4. That's a perfect square. 3 times 3 is 9. That's a perfect square. 4 times 4 is 4. 16, and so on. So right from the beginning at 36, when I broke it down into 6 times 6, these are both identical numbers. Therefore, 36 would be a perfect square. You can also see that there's an even number of groups when I break it down into the prime factorization. So if you can find an even number of groups, then you know that your number will be a prime number. So we're going to look at, a perfect square. If we look at numbers that are perfect squares, or we're trying to check to see if they are perfect squares, let's see if they break down into an even number of groups of prime factors, or if you can find two numbers that multiply or that break into that number, or multiply to that number that are the same. So for example, 20, again, you could do 10 times 2 or 4 times 5. Let's do 4 times 5. I know that 4 breaks into 2 times 2, and then we 5 doesn't break into anything, so we get 2 times 2 times 5. There is not an even number or an even group of the prime factors. And we can see that we can't even find two numbers that multiply to 20 that are the same. So this would be, no, that is not a perfect square. Moving over to 64, I can already find two numbers that multiply to 64. Again, you could find others. Okay, you could find other numbers that multiply to 64. But I'm going to stick with 8 times 8. So right away we can see, oh yeah, that's a perfect square because I found two numbers that are identical factors, right? But if we break these numbers down, 8 breaks into 4 times 2 times 4 times 2. And then 4, because it's not a prime number yet, I can break that down further into 2 times 2. I'm going to bring that down. I'm going to break that 4 up into 2 times 2. And then I'm going to bring that 2 down as well. So look to see if I can group these. So here I can group them into even groups. I have 2 times 2 times 2 and 2 times 2 times 2. Or you could break them into 2 times 2. You have 3 groups of 2 2s, right? But because of that, because you can group them evenly, then this is a perfect square. 64 is a perfect square. Now that we've dealt with perfect squares, let's deal with the, let's look to see if we can find the side length of these two squares. Now the side length will be directly connected to the square root. And we haven't looked at square root, but if I looked up here, if I was to take the square root, and I'll show you what the symbol for that is, of 64, the answer is 8. And you can always check on your calculator. If you type in 64, and you use this button that has a square root with a little 2, because there are other roots that you can do, third roots and fourth roots, we're only going to do square roots. So if you have this button on your calculator, even if it doesn't have the 2, then it is the square root. And you can check to make sure what the square root of the perfect square is. So for these types of questions where you're given the area, this is the area of the inside of the square, and you're supposed to determine the side length, what you want to do is you want to find out what two numbers multiply to equal 9 that are the same. Oh yeah, I remember, they're 3 and 3. And the units for the side length will be centimeters. The units for area are whatever your units are, in this case centimeters squared. Okay, so the side lengths are the values that multiply to equal the area. And they both have to be the same. Alternately, you could take the value of the area and take the square root to find the side length. So the square root of 9 is 3. And that is my side length. Over here, 121, you might recall, you might not, that two numbers that multiply to 121 that are the same are 11 and 11. So I get 11 centimeters for both the side lengths. Keep in mind the units. The units are very important. 11 centimeters for the side length, and then for the area is 121 centimeters squared. So that is how to find the side length. So we can think of perfect square as the area of the square and the square root as the side length, as we just saw. Now, determine the square root of each one of these. Again, for these ones, you can always just use your calculator. So I have the square root of 4, but we know that that's just 2. Square root of 49 is 7, and the square root of 144 is 12, because these values multiply by themselves. 7 times 7 is 49, 12 times 12 is 144, and so on. Finally, we're going to be looking at estimating each value, and then checking using a calculator. So the square root of 6, we know it's in between the square root of 4, which would be 2, and the next one up, which would be the square root of 9, which is 3. So we could estimate to this to be somewhere like 2.5 or something. Similarly with square root of 60, again, we can check these two. Well, let's just estimate first. So square root of 60, close to square root of 49. The next one up would be the square root of 64, which is 8. So let's say maybe 7.5 or something. Close to that. You could probably get a better estimate if you took a little bit more time. And 130, it's a little bit less than the square root of 144. So the square root of 121 would be 11. The next one up would be, of course, 144, which is 12 squared. So this is going to be somewhere above 11 but below 12, so we'll say maybe 11.5. Now we can check all these on my calculator. So the square root of 6 is actually 2.4. So I was close. square root of 60, and you could write these answers down, is 7.7. Right? So it's a bit closer to the square root of 8. And lastly, 130, the square root of that is 11.4. So we're pretty close with that one too. So just estimating, kind of seeing where it lies between, right? So which two square roots are on either side, and then guessing to see, checking to see which ones are close. Hopefully that lesson makes sense. If you have any questions, let me know. Yeah, just look it over and make sure you take notes on all this.